Hi, I'm Mikey Jeanson, a gameplay programmer with a background in Unreal Engine and C++. I've helped make several games including Your Average Bear, but now I'm a full-time UEFN developer, and this is Verse Boost. Hey everybody, welcome back to Verse Boost episode 15. Today we're going to be talking about access levels, public, private, internal, protected, and scoped. And we'll be talking about how to mix match them later as well. So if you haven't heard of that, haven't seen that, stay tuned. First thing I want to talk about is I have a survey going on right now. The link should be in the description. Here's a couple questions that are on it. Seems like I need to slow down a little bit, and some people are kind of split on whether I should be typing it out or the code should be already present on screen. Today we're not going to be talking about code as we are going over access levels. So access levels allow us to restrict or permit access to modules, classes, etc. They are used for project tidiness. There's not actually for security concerns. Okay, that's a big thing that maybe novice people might think is, oh, let me make it private so nobody can hack me. That's not what's going on. That's not how that works. Access levels are very important for making good APIs that will be used by others. And access levels are good for defining roles for classes, modules, etc. We'll talk about that a little bit more. And setting up well-defined access levels will help you simplify your programs by forcing intentional design decisions to limit public entry points. Like I say here, Creative Device has many methods that we don't see, but we do see on begin and on end, so we can have a well-defined and clear roles for those methods, right? We know what we're supposed to do in on begin and on end. But the private stuff, like has on begin been called yet, so we don't call it twice, that type of stuff is abstracted away from us. So let's do a quick metaphor. We have a microwave and an oven. So with an oven, there's many have-to-dos, right? You have to set the temperature. You have to wait for it to reach that temperature. Then you got to put it in the oven, wait for it to get to that point. Right when it gets to the time, you have to take it out. It's just not easy for novice users. I don't know if you could tell how I talk about using an oven, but I'm not the best at using an oven, right? I know how to do the basics, but don't ask me to do anything crazy. Ovens are complicated at the end of the day. I much more prefer using a microwave, okay? If I need something to get hot, I like to just be able to press start and wait 30 seconds. Oh, it's not hot enough. Press start again, or just put the time in. It's much easier. I don't have to do a bunch of waiting. There's not a lot of setup. It's just ready to go right away, and it's super easy for novice users, like our friend Curious George here. If we thought of the oven as an API, we'd say there's many access points, there's many public entry points. It's not easy to use without reading the documentation, and it's a sloppy AI. Microwave, on the other hand, there's limited access points. You don't really need to read that much to understand what's going on. It's a toy API, if you will, from our boy Jake Peralta. And I had this on Twitter. This is a good example, or not a good example, but it's kind of just talking about software design, and that's kind of what we're talking about today's video with access levels. Is like you have, these two things interacting, and there's a bunch of complicated crap going on everywhere, and, the professor in this class says, put something in the middle to do the solution. That's not exactly what we're talking about today, but what we are talking about today is like getting rid of all this complicated stuff, so that we can have cleaner entry points to our classes and to our modules and stuff. So if we were making like a tycoon, for example, let's say this is like one of the purchasable things in our tycoon. In a bad API with a bunch of public methods, you'd have like all these, right? And then in a good one, you'd have like 4 public methods: load, purchase, unload, unlock. And then you have all these like private or internal helper methods. I would say private in this case, but that you do the complicated stuff within that class, within that module or something. So you don't have a manager that has to make sure all these things are called before you call something else, If we want to call purchase, well, first we got to check if the balance, right? If we're using this side. But in here, we just call purchase, and it checks, and maybe it returns a logic variable, whether it's true or false, whether it worked or not. So I would advise you to have less public methods and more private methods inside of your classes to limit the access points. And that's because if you have a clean API, even if you work alone, it will help you, because I just promise me that you will forget how something works. Maybe it's a month later, 2 months later, whatever. Maybe it's a week. But you'll forget how to use something, but you'll want to reuse some of the code you wrote. Well, you don't want to have to, step through all of your module and read everything that's going on. And if it's so complicated and everything, test it when you make it, so it works. And then make sure you just have a clean entry points, have an expected output when you have a known input, right? So that you don't have to do all this stuff, When you look at your class later, the API later, you'll be like, oh, this is how I operate with the class. You have well-defined names, and then you have few public methods. So I don't have all these public methods. Which one do I call again? I can't remember which one I call. You just have 4. It's okay, I know what I need to do. Notice how all these do their own thing, right? They don't step on each other too much, right? And so on these, they're all over the place. Which do I call them in the right order? How do I do it again? That's the stuff we don't want to be worrying about. So let's go over the access levels. First, let's start with public. Public's very simple. It's basically accessible anywhere you have access to that thing. So if you have access to a class, you have access to all of its public members. If you have access to a module, you have access to all of its public classes and stuff like that, public methods and everything like that. Things should be public when you want other modules or classes to be able to use them. And the key note here is outside of a module, members are public by default. So if you just opened up a brand new verse file and it's in the main folder, it's not in a module, then it will be public. Everything will be public. The members, the methods, and everything, unless specified otherwise. Private, this is the other key one that we will be talking about. And private means it's only accessible within the same class. Even subclasses can't even access private members of the parent class, okay? So it's specifically to that class. Things should be private if they don't matter outside of its current class, okay? So create advice likely has many variables that we never see in the API. Like I said, has onBegin ran yet? There's probably an has onBegin run variable. We don't see that because it doesn't matter to us, because we're not the ones calling onBegin. It's somewhere else in the code base, right? An example would be the helper methods that we showed in the oven microwave example, right? For purchase and everything. Does they have enough money? That could be a helper method, and it could be private because we don't need it in another class. If we do need it in another class, maybe we move that into a module and then we make it a public method, right? And then we have internal. Internal is accessible anywhere within the same module. So unlike private, if you have an internal method within inside a class and you have another class in the same module, you can call any of those methods or access any of those variables and members within the same class. So for an example, we have our removable agent function, and you'll notice I have all these internal things. Everything's internal, right? And in our agent listenable class, different class, we're using the removable agent function, and we are able to set these variables and members because they're internal. If we were to make the function private, right, we'll get a bunch of errors because it's less accessible than the class itself. But now we can't, set function here. Okay, so internal means that we can use it anywhere within this module. Okay, so if anywhere I want to use it, I can use it. By default, members are internal once you're inside of a module. Okay, so you'll see that in module class is inside access levels module. When I try to access it here, it fails because it's not available because it's internal. If we were to add public to this, then you'll notice now we can use it, except we have to make this public also because it has to be as accessible as the class. But yeah, you get the idea. That's why we have the error there. Next we have protected, and protected is a lot like private. Okay, it's meant for things that aren't accessible for other classes, but it is meant to be used by subclasses. And a lot of the times you might write protected for a private method that you intend to be overwritten, like in an interface or an abstract class. Use protected when a thing should be private to everything except for the inheriting classes, like I said. For an example of protected, you'll notice that all the lifetime methods for a component from scene graph are protected because they shouldn't be called from outside of the class and outside of anything that inherits that class. No, it should only be called by things that are aware of component and itself, right? Itself and everything that derives from it. So you have this rectangle class that has a couple protected variables and a protected method. You'll notice that in our square class that inherits from rectangle, we override the width and we could override the height too. No problem there. We could override it. But if we made this private, let's make height private, then you'll notice that we can't access it anymore, even though we are inheriting from rectangle. And you'll notice that our get perimeter from rectangle is protected, and when we want to print our perimeter and from our square class, we are able to call it. And this is, we're calling a public method outside of this class. Somebody's calling it, but we're able to use get perimeter because it's protected, because it belongs to the rectangle class, and because it's protected, we inherit that class and we get all of its protected variables. We get access to all those protected variables. If you made this private, right, it's still there in the square class. You just can't access it through the square class. Does that make sense? So if this is private, we can only access it within this class. But since it's protected, anything that inherited can. But outside of it, right, we try to use it in our example has area, we can't get the thing, right? We need to use these getters, right, for get height and get width because they're protected. So we can't get those values because they are protected and they're not accessible from outside of that class. Many of you are probably familiar with getters and setters, but I would wonder if you are familiar with mixing and matching access levels. You'll see here that I have var private value public. What does that mean? That means that it is not allowed outside of this class because it's private to set value. However, you can read from it. So internally, we can set the value, right? But when we try to set it over here, we can't set because it's a private variable. If we try to read from it, though, we have no problem reading from it. This variable, we have the public and private. It will compile, I know that, but it doesn't work. So you can fool around with mixing and matching on your own. Like I said, there's a different stuff you could do, but most of the time you're going to be wanting to do something like this. Maybe protected here, or internal there, and then public here, because you want a public read, but not a public write. Last access level is scoped, and scoped allows you to whitelist certain modules so they can access internal classes, methods, etc. So if you're familiar with friend in C++, if you're coming from Unreal Engine, which I know many of you aren't, maybe you know it from other languages as well, it behaves similar to that, and it's a lot like internal. It's not identical, but basically you are saying like, hey, this module can use this like method or this module or whatever, this class, right? And it's like whitelisting it. It's like, hey, my rectangle class can use this, but nothing else can use it unless it's inside the module that I defined it in. I'll show you guys an example. So because scoped behaves similar to internal, this scope Sally doesn't actually mean anything in this case, right? Because if this was internal, it would behave the same way. We can still read from these values and use Patrick's class. But you'll notice here, when I do two modules that are different modules for Adam and Eve, when we try to use Eve's thing too, where it's not scoped to Adam, right? It's scoped to Sally and Dre, we can't read from the thing to class. But if I were to add Adam in our scoped, now I can read from it. Okay, so you see how that works? Can't do it then, now I can. So we're basically whitelisting Adam, right? So that it can use the thing too. There's a bunch of different nuances to it. I've kind of played around with it in this file that's available on my website, like all the other ones. But you guys could play around with it a little bit and see how everything works. Like I said before, these things are very important to the design of your code base, your API. You really want to have a clean one. It really benefits me if you want somebody to tell you to do it. I use it all the time, and it's really helped me as a programmer become a better programmer because, like I said way in the beginning, it makes you do intentional decisions, and it makes you design things that don't look like this, on the left. They look like this on the right, and they're very simple, and they're very easy to reuse. You can pick up this module and just plop it onto something else because I don't have all this, bloated stuff to worry about. I have very simple API to understand, and I can go months without seeing it and then pick it up and be like, read, like 3 comments and be like, okay, I know exactly how to use this again to get the desired result I want. I don't know exactly what's going on internally, right? I don't know all the wheels. I can't remember all that stuff, but I know if I call load, it's going to bring the props up, right? That are loaded for that player. So, like I said, use access levels, make intentional decisions, and you'll be a much better programmer than you were before then. If you guys have any questions, I'll be in the comments. I'm very sorry for not uploading for a month. I was busy, but that's no excuse, I want to make these videos for everybody. So if you enjoyed it, please leave a like. Hit me up on Twitter. I'm always trying to check the DMs and on the comments. So I'll try to get another episode done next week and keep these things rolling. Like I said at the beginning, fill out the survey, and the code will be in the description or on my website, but which will be linked in the description as well as the survey. All right, thank you guys so much for watching. I know this was a long one, so if you got to the end, have a great weekend. Goodbye.